sir, you are audible.
Okay. So generally non-metals are non-sonorous in nature, means they do not produce any sound upon heating. And next point, they have the low melting point as well as the boiling point. Except diamond and graphite, they have the high melting point and the boiling point. Okay. When you are studying the physical properties of metals and non-metals, the exceptions are very, very important. Clear?
Yes, sir.
Yes, sir, clear.
The next one, they have the low densities, they have the low tensile strength. Low tensile strength, now they will break easily. And one more important properties of non-metals are they exist in all the three states of matter: solids, liquids, as well as gases also. So non-metal will exist in all the three states of matter. Here examples also given. Solid non-metals are carbon, sulfur, phosphorus, and iodine. Bromine is the liquid non-metal. And what about the gaseous state? Hydrogen, oxygen, nitrogen.
Hydrogen, oxygen, nitrogen, chlorine, helium, and neon.
Okay. Today's homework for you is first homework. You have to study all these things, whatever you discussed in the class. Apart from this, I said you right. So what are the 7 metalloids are there? What are the 17? Sorry. If you take the periodic table, 17 non-metals are there. What are these 17 non-metals? 7 metalloids. And what are the 11 gaseous elements? You have to list down that one, okay? 11 gaseous elements. What are those? You have to list it
Yes,
down
sir, okay.
completely. Next 17 non-metals. What are those? Listed down completely. 7 metalloids. What are those? Listed down completely. Understand?
Yes, sir.
Yes, sir. Sir, shall we submit this homework in the group or tell you tomorrow in the class?
Just you can show to me tomorrow in class. That's better.
Okay, sir.
Now, any doubts in the physical properties of metals?
No,
Sir,
sir.
no doubt.
Exceptions are very important. Okay. Then shall we move to chemical properties?
Yes,
Yes.
sir, sure.
Now, first chemical property is electronic configuration. What is the meaning of electronic configuration?
Sir, the arrangement of electrons in different shells around the nucleus in an atom.
The arrangement of electrons around the different shells or different orbits around the nucleus in an atom. I hope you both knows how many orbits are there and that how many electrons can accommodate. K shell,
Yes, sir,
L
2n
shell,
square, the formula.
2n square. What about Vedika?
Yes, sir.
Do you remember this homework?
Sir?
Do you remember this homework? What we discussed in the special class?
Yes, sir.
Do you have that notes?
Yes, sir.
Just go through it also, okay? Already discussed all the things in the special class itself. Electronic
Okay, sir.
configuration, structure of the atoms. Okay? So if you
Yes, sir.
take any metal, generally metals are electropositive in nature, right? Metals are
Yes, sir, they form
electropositive in
cations.
nature. That means they will lose the electrons. Generally, metal will lose the electrons to get the octet configuration in the outermost shell. That's why they form electropositive nature. So most of the metals will have only either 1, 2, or 3 electrons in the outermost shell, or you can call it as valence shell. Okay. Most of the metals will have only 1 or 2 or 3 electrons in the outermost shell, so that they will lose these 1 or 2 or 3 electrons from the outermost shell to get the octet configuration. Clear?
Yes, sir.
So if you take first group elements, all are metals only, right? Then how many electrons are there in the first group in the valence shell?
So 1, 2, or 3.
If you take periodic table,
So can you repeat your question?
if you take the periodic table first group, how many valency electrons are there?
So 1,
One. Very good. Second group,
2,
2,
two. Third in the group,
3.
three. Very good. So most of the metals will have only one or two or three valency electrons in the outermost shell. Okay.
yes, sir, okay.
And next property already we discussed, right? Electropositive nature. So always they have tendency to lose the electrons, or they will donate the electrons to other elements in the periodic table. So that's why they are called as an electropositive in nature. Clear this one.
Yes,
Yes,
sir,
sir.
clear.
Next, electronegativity. Generally, metals are highly electropositive or highly electronegative.
Sir, can you repeat?
Metals are generally highly electropositive in nature or highly electronegative in nature.
They're highly
Electropositive.
electropositive.
Positive in nature, right? Because they are losing the electrons. That's why metals will
Yes,
have
sir.
low electronegative nature because they cannot gain the electrons. That's why they have very low electronegative nature. Okay.
Okay, sir.
The next one is the formation of oxides. Then, whenever the metal reacting with the oxygen present in the air, it will form metal oxide. That is a constant. Whenever the metal react with the oxygen present in the air, it will form metal oxide. But this metal oxide is acidic in nature or basic in nature?
The basic.
Basic in nature. Vedika, understanding?
Yes, sir.
Whenever the metal react with the oxygen present in the air, it will form metal oxide. All the metal oxides are basic in nature. What is the meaning of acid or what is the meaning of base?
Sir, the pH more than 7 is called as basic, and less than 7 is acidic, and 7 or 7.5 is neutral.
7 itself is neutral, not 7.5. Only 7 is
Yes,
the
sir.
neutral. Okay. Next, Vedika. Vedika,
Yes, sir.
what is common among the acids and what is common among the bases? What is a common thing among the acids and what is a common thing among the bases?
So may I tell?
1 minute. Vedika,
Sir, acids are H plus ion and bases are OH minus ion.
very good. Yeah, Sahu.
Sir, as the name suggests, acids have pH less than 7 and bases more than 7.
Yeah, but the common thing among the acids are H plus ions. The common thing among the most of the bases are OH minus ions. In that way, you can identify easily. Okay.
Yes, sir.
So the common thing among the acids are H plus ions, and common thing among the bases are OH minus ions. So formation of oxide. Whenever the metal react with the oxygen present in the air, it will form metal oxides. So metal oxides are basic in nature. What is the nature?
Basic.
Basic.
Okay. Now clear up to this. Now the base which
Sir,
yeah,
sir, is basic and alkaline the same?
I will tell you that point on the next. Okay.
Okay, sir.
If the base dissolve in the water, that is called as an alkali. If the
Okay,
base
sir.
dissolving in the water, that is only called as an alkali. If the base does not dissolve in the water, that means that is not alkali. Understanding? Those bases which dissolve in the water are called as an alkalis. Clear this point?
Yes, sir, clear.
Now tell me whether all bases can be alkali?
No, sir.
Yes or no?
No, sir.
Vedika?
Sir, I don't know.
Just now I said the main point, right? The base which dissolve in the water is called as an alkali. Clear this point?
Yes, sir,
Yes,
clear.
But if all the bases can be called as an alkali,
no, sir.
no,
No,
right?
sir.
But can we call all the alkali as a bases?
Yes, sir. We can call.
Whether all alkali are bases, can we call?
Yes, sir.
Yes, because we are calling the some bases only as alkali, right? That means all alkali can be
Yes,
bases
sir.
only, right? Understand or not, Vedika?
Yes, sir.
Tomorrow I will ask you again whatever the topics I'm teaching you, how to revise today itself.
Yes, sir. Sir, can you share the PDF in the group as well?
Yes, sir. Please.
Yeah, sure. But don't share this PDF with your friends again and all, okay?
No, sir. Will
Okay.
not.
Okay, next one. Okay, these 2 points are clear for you till now. Then, you know alkali metals, right? The first group is called as an alkali metals. Why they are calling it alkali metals? Why they are calling it alkali metals?
Sir, can you repeat your question? I was unable to hear that.
Okay, now we can call first group elements in the periodic table as the alkali metals. Why they are calling as alkali metals? Because the first group elements react with the oxygen, it will form basic oxides, right? Metal oxides. Metal oxides are basic in nature, and again, those metal oxides will dissolve in the water. Suppose if we take sodium, sodium reacts with the oxygen to form sodium oxide. Again, if you dissolve the sodium oxide in the water, now it will form sodium hydroxide. Understanding?
Yes, sir.
Yes or no?
Yes, sir.
That's why the first group elements in the periodic table are called as an alkali metals. That means all the metals in the periodic table will form the bases. Those bases all are dissolved in the water. Okay, clear?
Okay, sir.
Then you can see one more term here, amphoteric oxides. What is the meaning of amphoteric oxides? What is the meaning of amphoteric oxides? Those are the oxides which can react with both acid as well as the bases. Those are the oxides which can react with both acid as well as base. Okay,
Okay, sir.
any confusion?
Sir, can you repeat amphoteric?
Sorry,
Sir, can you once more explain?
metal oxide, right? Metal oxides are basic in nature. Metal oxides are basic in nature actually. So if the metal oxide dissolve in the water, they will form the alkalis. Clear up to this? Still you have the doubt. Tomorrow class I will start from here itself, from the formation of oxides. Okay.